Welcome back, everybody, as we continue our magical journey through the world of solving linear equations. Today, our learning target is I can solve a two-step linear equation. One of the things we have to remember is that when we solve equations and we try to isolate the variable, we have to work backwards in order to get it. In order to work backwards, let's take a look at what we normally do. When you do a computation, like we did in the last unit, normally you follow the order of operations, or PEMDAS. Parentheses first, then exponents, then the multiplication and division, and then finally the addition or subtraction. Well, when we solve equations, since we're working backwards, we're going to do the order of operations backwards and undo all of the steps that would normally be done. And the thing I like to call it is Algebra. First, we'll undo addition and subtraction, then we'll undo multiplication and division, then exponents, although that won't come till later, and then the very, very last thing we undo is what's in parentheses. And that's the one that people trip up on sometimes. So one of the things you'll have to remember as we solve different types of equations like this, anything in parentheses, that doesn't get done until the very end of the problem. So let's go do some of these. The first one we have is 28 equals 2/3 x minus 7. And just like we did with the one-step equations, we have defined the x, so there's the x right there. And now let's think about what's happening to the x. Well, in the correct order of operations, you do parentheses, exponents, which there are neither of. So then you do multiplication or division. So that means whatever number I plug in for x would be multiplied by 2/3. And then after that comes addition and subtraction, so the second step would be minus 7. So these are the steps we did. Now we have to undo them. And again, since we're working backwards to solve the equation, we'll undo things in the reverse order of operations, Algebra. So we look, is there any addition or subtraction to undo? And so we start at the back. To undo the minus 7, we have to add 7, and then we keep working backwards. Next would come, we'd undo multiplication or division, and so to undo the multiplying by 2/3, I'd have to multiply by the reciprocal, which is 3/2, and now I have the steps I need to solve this equation. So, first I'll add 7, because we want to zero out minusing 7. And so this will give us 35 on the left side. And on the right side, it'll be 2/3 x plus 0. But of course, we're not going to write the plus 0. That's just a waste of ink. Doesn't change it. So now we have 35 equals 2/3 x. And now we're going to multiply by the reciprocal, the 3/2. So we multiply by 3/2 on both the right side and on the left side. That's going to make the 2/3 and 3/2 cross out to 1, so that gives us 1x, which of course we don't have to write the 1, because 1 times x is just x. And then we do 3/2 times 35, and we end up with 105 halves. And remember, since we're just doing straight up algebra here, don't write a mixed number, don't write a decimal. The fraction of 105 halves is perfectly good, and that's what we prefer. Okay, second example. 9 plus 3x equals -2. So let's find our x. There he is, right there. Now let's think about, what are we doing to the x if we use order of operations? Whatever number I plug in for x is going to get multiplied by 3 first, because of PEMDAS. And then secondly, we're going to add the 9. Okay? So now if we want to solve it, we got to work backwards. So working backwards, first we have to undo adding 9. So we undo that by subtracting 9. And then we got to undo multiplying by 3. So we're going to divide by 3. And now we just work our scale. Just start working both sides of the equation. So minus 9 to get rid of that 9 and make that 0. So minus 9, it's 0 plus 3x, which gives us 3x, equals negative 2 minus 9, negative 11. Now we divide by 3 on both sides. That just will give us 1x. So x equals, and then that doesn't reduce, so we get x equals negative 11 thirds. Okay, third example. Same thing, let's look. There's the x. What's happening with correct order of operations? Well, it's being divided by negative 2. You'll be negative 2. Well, if you see this minus sign here, that means x is being divided by a negative 2. And then negative 9 is being added to it, so we think about it. Instead of adding negative 9, we can just think about we just subtracted 9. Okay? Now, again, work backwards, undo everything. So to undo minus 9, I have to add 9. And then to undo divide by negative 2, I have to multiply by negative 2. So here we go. Work both sides of the scale, keep it balanced. So add 9 on the left, add 9 on the right. That's 0, so now we have 0 minus x over 2, which is opposite of x over 2, equals 29 plus 9. That gives us 38. And then to get rid of dividing by negative 2, we multiply by negative 2. So that divides out to 1. The negative 2 times dividing by negative 2. So I have 1x, or just x, equals 38 times negative 2, which gives me negative 76. So x equals negative 76. Okay, fourth one. Now, before you yell at me for this and be like, pause, you're doing it all wrong, man. I never learned this way. My 8th grade teacher, she taught me to do it a different way, and man, pause, you just crazy, and I don't want to hear it. Just trust me for a sec on this one. The way you probably would think to solve this problem would be a little longer. It would take 3 steps, but watch this. I'm going to solve it in only 2 steps. Because you normally do things in parentheses first when going forwards, that's what would happen. We'd take a number, we'd plug it in for x, we'd subtract 15 because it's in parentheses, and then we'd multiply by the 3 second. So now when we're undoing things, whatever was in the parentheses is going to be the last thing we're going to touch. So to get rid of multiplying by 3, I have to divide by 3, and to get rid of subtracting 15, I have to add 15. Okay, here we go. Watch how quickly this problem can be solved. Divide by 3, divide by 3. So that gets rid of that. It'll be like 1. When you distribute 1 to both of those, it's just the same number. So now you have x minus 15 equals 87 divided by 3. That's 29. And then now look, all we got to do to finish, add 15, x equals 44. Boom. 2 steps, solved it quickly, and when we do some other types of equations later this year and in Algebra 2, you'll thank me for showing you this way that you can solve these linear equations. Okay, last one. We have x plus 7 all over 6 equals 17. So same thing, remember a fraction bar is like a parentheses. So we're going to find the x, and any number we plug in for x, we would add 7 to, and then divide by 6. So now, if we're going to undo the steps, since the fraction bar is like a parentheses, whatever's up here on top of the fraction bar is going to be the very last thing we get rid of when we're working backwards to solve the equation. So first, we got to undo dividing by 6 by multiplying by 6. And secondly, we have to undo adding 7 by subtracting 7. So here we go. Multiply by 6. Multiply by 6. That's now just going to be 1. And we can distribute the 1 to the x plus 7, which will make it x plus 7. Notice too, we didn't touch anything on the top with the 6. All multiplying by 6 did was make the bottom 6 cross out, because this just multiplies to 1, and when we distribute the 1 to the x plus 7, it's just x plus 7, the same thing. So now we have the 17 times the 6. Okay, so 17 times 6, that's 102. And now all we got to do to finish the problem, subtract the 7, subtract the 7, x equals 95. So, that's how you solve two-step equations. Remember ASMDEP, work backwards through your order of operations. And if it helps you, write out what you would do if you plugged a number into x, and then just undo things working backwards, and you can easily write out the steps that you need to solve and to get the value of the variable. So that's all for solving two-step equations. Now go practice.